In today's video, we're going to be talking about a proof of the quadratic equation. So to prove the quadratic equation, what we want to start off with is we want to start off with a quadratic in standard form. So y equals ax squared plus bx plus c. The first step to proving the quadratic equation is to complete the square on a quadratic in standard form. So the first step is to factor the a out of the first two terms. Notice here, when you factor something out, you're dividing. So in this case here, a divided by a is 1. B divided by a is going to be b over a. Notice if I redistribute this a, the a's will cancel and you will get your coefficient of b as you wanted. Now you identify your b variable. In this case, it's b over a. You divide that by 2 and you square it. Well, I can rewrite the 2 as 2 over 1. And now you're taking fraction divided by fraction. So now we multiply by the reciprocal, the flip. That becomes 1 over 2. Change division to multiplication. This becomes b over 2a, quantity squared, which is b squared over 4a squared. Remember, when you square a rational number, you square the top, square the bottom. So therefore, that's the number I'm going to add and subtract into my quadratic. So we've got y equals a x squared plus b over a x, and then I'm going to go ahead and add b squared over 4a squared, subtract b squared over 4a squared. And notice here, I'm just going through the exact process of completing the square, but we're doing it with letters here instead of numbers. So now, just like when you're normally completing the square, these first three terms will factor into a perfect square. So the square root of x squared is x, right? We're going to write all this back down here. So notice I put the c down with the c, the bracket with the bracket, wrote that back down, wrote the a back down. And now, like we were talking about, the square root of x squared is x. The square root, if you take the square root of b squared over 4a squared, you actually get b over 2a. Because again, when you take the square root of something, take the square root of the top, the square root of the bottom. Square root of b squared is b, square root of 4a squared is 2a. Now you just copy the sign in front here, which is positive, go to positive, and now we're on our way. So again, just like with numbers here, I want to be able to collect these two together. Can't do that unless I distribute this a. So now I distribute the a. When you distribute that a, you're going to lose a power on the a and the bottom, right? Because what's going to happen here is, obviously, we distribute the a the first term. When you distribute to the second term here, you're going to end up getting a times a over 4a squared, and one of the a's will cancel, and you lose one of the exponents. And then lastly, don't forget to put down that plus c. All right. So now we're here. And now we've completed the square. So now I have my quadratic in vertex form. Just as a side note here, notice the general form of a quadratic is the vertex here would be negative b over 2a, and the y-coordinate of your vertex would be negative b squared over 4a plus c. So we're going to come back to this in a later lesson and talk about the usefulness, which is very useful in this generalized equation for your vertex. Okay, now continuing on, we want to focus our attention on solving, or proving, I should say, the quadratic equation. Now again, to find the quadratic equation, what we do is you're looking for roots. If you're looking for roots, you have to set your y value equal to 0. So I'm going to set y equal to 0. And now our next goal is to solve for a, or x, I should say. So now if I want to solve for x, we got to bring our numbers to all to one side. So I'm going to go ahead and add b squared over 4a and subtract c. So I'm going to get b squared over 4a minus c equals a times x plus b over 2a quantity squared. Now we're going to go ahead and get a common denominator. So I'm going to multiply top and bottom by 4a. So what I did here was I multiplied by 4a and divided by 4a, and that to get a common denominator. Now that I have a common denominator, I can put that all together. And this becomes a x plus b over 2a quantity squared. And now again, I want to solve for x. I have to get the a out of the way here, so I have to divide across by a. So if you divide across by a here, you're going to get b squared minus 4ac divided by 4a. You take the entire expression divided by a, and that's going to be x over b, x plus b over 2a quantity squared. Now as we continue on here, to divide this out here, this is really fraction divided by, now it's a fraction. So you multiply by the flip, and when you'll see, if you multiply by the flip here, this just becomes 4a squared is x plus b over 2a squared. Okay, so now I want to go ahead and take the square root of both sides of the equation. When you take the square root, you add the option of positive and negative both working here. All right, and now I want to go ahead and solve for x. So I'm going to subtract b over 2a on both sides. Then I want to get x by itself, remember. Okay. Now when you take the square root of a number like we discussed, you take the square root of the top and square root of the bottom. And what happens here is the square root of 4a squared is going to be 2a. And now I can get a common denominator here. Since I have a common denominator, we now have our quadratic equation. And this is, again, like we talked about, this is going to be x equals 2. Okay, so therefore, here's a proof of the quadratic equation. Okay, so feel free to review the proof here. Essentially what you're doing in this proof is you're completing the square on a generalized quadratic. And from there, we end up getting our quadratic in vertex form. Since your quadratic equation deals with the roots, we set y equal to 0, because that's what it means to have roots. Your y value has to be 0. And then we just isolate for x here. So I'm just going through the algebra of isolating for x, and then we get x to one side, and out pops your quadratic equation. X equals negative b plus or minus the square root of b squared minus 4ac, the entire expression divided by 2a. Thank you.